Hello, space enthusiasts. Today, we're thrilled to share an extraordinary discovery from NASA's James Webb Space Telescope. Get ready to journey beyond our solar system to uncover the secrets of an incredible exoplanet. An international team of astronomers has achieved a remarkable feat by directly imaging an exoplanet located roughly 12 light-years away from Earth. This distant world is known as Epsilon Indi Ab, and it holds the title of one of the coldest exoplanets ever observed. Epsilon Indi Ab is a giant, with a mass several times that of Jupiter. It orbits a K-type star, Epsilon Indi Ab, which is similar in age to our Sun but slightly cooler. Using the coronagraph on Webb's mid-infrared instrument, the team was able to capture this stunning image. Directly imaging exoplanets is a significant challenge. Until now, only a few tens of exoplanets have been directly observed by space and ground-based observatories. This discovery is a crucial addition to our understanding of distant worlds. Our prior observations of this system have been more indirect measurements of the star, which actually allowed us to see ahead of time that there was likely a giant planet in this system tugging on the star. That's why our team chose this system to observe first with WebbSat team member Caroline Morley of the University of Texas at Austin. This discovery is exciting because the planet is quite similar to Jupiter. It is a little warmer and is more massive, but is more similar to Jupiter than any other planet that has been imaged so far, added lead author Elizabeth Matthews of the Max Planck Institute for Astronomy in Germany. Previously imaged exoplanets tend to be the youngest, hottest exoplanets that are still radiating much of the energy from when they first formed. As planets cool and contract over their lifetime, they become significantly fainter and therefore harder to image. Epsilon Indi Ab is one of the coldest exoplanets to be directly detected, with an estimated temperature of 35 degrees Fahrenheit, 2 degrees Celsius, colder than any other imaged planet beyond our solar system, and colder than all but one free-floating brown dwarf. Cold planets are very faint, and most of their emission is in the mid-infrared, explained Matthews. Webb is ideally suited to conduct mid-infrared imaging, which is extremely hard to do from the ground. We also needed good spatial resolution to separate the planet and the star in our images, and the large Webb mirror is extremely helpful in this aspect. Astronomers have imagined planets in this system for decades. Fictional planets orbiting Epsilon Indi have been the sites of Star Trek episodes, novels, and video games like Halo. Now, we get to see a real planet there and begin to measure its properties. Epsilon Indi Ab is the 12th closest exoplanet to Earth known to date and the closest planet more massive than Jupiter. The science team used radial velocity, which measures the back and forth wobbles of the host star, to detect the presence of the planet. While we expected to image a planet in this system, the planet we found isn't what we had predicted, shared Matthews. It's about twice as massive, a little farther from its star, and has a different orbit than we expected. The atmosphere of the planet also appears to be a little different than the model predictions. The team believes there may be significant methane, carbon monoxide, and carbon dioxide in the planet's atmosphere that are absorbing the shorter wavelengths of light. This could also suggest a very cloudy atmosphere. Direct imaging of exoplanets is particularly valuable for characterization. Scientists can directly collect light from the observed planet and compare its brightness at different wavelengths. The team hopes to revisit Epsilon Indi Ab with Webb for more detailed observations. NASA's upcoming Nancy Grace Roman Space Telescope will use a coronagraph to photograph Jupiter-like worlds orbiting Sun-like stars, paving the way for future missions to study even more Earth-like worlds. These groundbreaking results were taken with Webb's Cycle 1 General Observer Program 2243 and have been published in the journal Nature. Thank you for joining us on this cosmic journey. Stay tuned for more exciting discoveries from the James Webb Space Telescope. Until next time, keep looking up.